we start? Hello. Hello. हॅलो डॉक्टर पल्लवी देशमुख.
हा सर, गुड मॉर्निंग
आवाज
सर.
येतोय का माझा?
हो सर, येत आहे.
Almost all the participants have joined. So shall we start?
Yes sir.
As usual, let me take your attendance first. Dr. Dipti Malviya. Dr. Dipti Malviya.
Yes sir, present.
आवाज नाही येत आहे.
Present sir.
डॉक्टर उषाली पारखी.
प्रेजेंट सर.
नीतू अमलानी.
Present sir.
डॉक्टर पंड्या.
Present, sir.
मिसेस मिरल राजदेव.
Present, sir.
डॉक्टर सुपर्णा मुरकुटे. डॉक्टर अमित काबांडे.
Present, sir.
डॉक्टर अर्चना महाकाळकर.
Present sir.
डॉक्टर विनोद डोंगरवार. डॉक्टर अरविंद सोमनाथ है. डॉक्टर श्रुति घरडे. डॉक्टर श्रुति घरडे.
सर I am present.
पल्लवी देशमुख आहे. हो, सुपर्णा मुरकुटे पण आहे.
हा.
श्रुति घरडे. I think she is yet to join. Anyway, मीनाक्षी कांबळे. डॉक्टर मीनाक्षी कांबळे मॅडम.
Yes sir.
डॉक्टर शील. डॉक्टर शील. डॉक्टर शील. मिस्टर विवेक माणे.
Present, sir. Shield, sir. Joined, sir.
पण he's not responding. Anyway, I think he's facing some problem of his mobile.
Oh, sir. Network connectivity नहीं है, sir.
There is no network connectivity. Anyway, Dr. Rajesh Sonkusre.
Yes, sir. Yes, sir. Present, sir.
Yeah, very nice. Dr. Vishal Daulatkar. Dr. Swati Yadav.
Sir, Vishal Davlatkar present, sir.
Oh, present. Dr. Swati Yadav.
मेरा आएगा.
Mr. Karkata.
Yes, sir. Present.
Miss Kani Mozi.
Present, sir.
Dr. Shikha Awasthi.
तो मेरा हो गया नहीं तो प्रोटेक्शन के लिए भी थोड़ा सोचना पड़ता.
After enjoying the yesterday Sunday, shall we start today our session? Shall we start our first session?
Yes sir. Yes sir.
Yes,
Our guest speaker have also joined. Dr. Shalini madam.
Yes, sir, I can hear you.
Yeah. Our guest speaker, today's guest speaker for the first session, I would like to welcome Dr. Shalini madam on behalf of the UGC HRDC Center and in association with the Sevadal Mahila Mahavidyalaya Nagpur. She is holding the post of Principal Scientist at National Environmental Engineering Research Institution. She is from Water Technology and Management Division. And today, she will be presenting her presentation on the restoration of the degraded land in the warming world. So, I think I have given this responsibility to one of the participants. So, kindly elaborate the biodata of madam.
I'm happy to welcome the resource person, Dr.
Yeah.
Dr. Dhyani, who is the principal scientist at the CSIR National Environment Energy Research Institute, NERI. She is Asia Vice Chair and Steering Committee member in the Commission on Ecosystems Management of IUCN and visiting scientist Center for International Forestry Research, ICRAF, Bogor, Indonesia. She works on interlinkages between socio-ecological systems, following diverse knowledge systems and sustainability science approaches for ecosystem health assessments, and implementing nature-based solutions for disaster risk reduction and climate change adaptation. She is experienced in multi-sectoral integration in climate-sensitive restoration for developing resilient landscapes by improving corporate community partnerships. She has been the lead author of the IPDA's Global Thematic Assessment on the Sustainable Use of Wild Species and the Asia Pacific Regional Assessment of Biodiversity and Ecosystem Services. She has to her credit many research publications in journals, edited books, and popular articles on various areas like nature-based solutions in reducing climate change, land degradation, disaster risk, and promoting biodiversity. With this brief introduction, I welcome you, ma'am, to take over the session.
Thank you, Madam Kanimozi and Professor Meshram sir for this kind invitation. And I'm sorry for compelling you to prepone my lecture for today. I'm really happy to be part of this UGC program and I'm happy to share some of my experiences. So I'm sharing my screen first. Just confirm me that you are able to see my presentation.
Yes, madam.
Yes, ma'am.
Yeah,
Yes,
and I
ma'am.
am audible as well. So as you know, land degradation is one of the biggest concern for this planet and also one of the major concern for the Anthropocene. So my present day topic of this lecture is restoration to address land degradation in the warming world. As you know, India and China are the forerunners, and one of the largest areas in these countries are under degraded condition. So it's very important that we talk about understanding, reversing, and halting land degradation using appropriate restoration strategies. This has been one of my very favorite slides, and I want to share this with you all as well. As you know, and you may be well aware of many of these important international ongoing development and discussions, basically 2050 Sustainable Development Goals, Kunming Montreal Global Biodiversity Framework that was accepted in December 2022 after the Nagoya Protocol and Aichi targets were concluded after 10 years of their functioning in 2020. We also have a lot of work going on with G20, where India is right now having the presidency. India is also partner of nationally determined contribution for reducing climate change in the country and neighboring areas. And then UNCCD is also talking about land degradation. But why I want to show this slide to you all is you can see that peak disaster risk reduction, climate change, or even realizing the benefits of land degradation, biodiversity, conservation of ecosystem services, and restoration of degraded land is one of the very cross-cutting areas. Unless we address conservation of biodiversity, restoration of our ecosystem, it's very tough to actually meet not only climate, not only biodiversity, but also reducing disaster risk reduction and sustainable development goals locally. Now, there was a common belief few years back, or I must say a few decades back, that we have abundant land resources. So that was one of the reasons we have taken land, soil, and soil-based resources in a very careless manner. And this negligence has actually paid us a lot. We know that a larger part of our country is degraded in one condition or another. And this problem is not only in our country, but also in neighboring areas and also across the world. And this is slowly increasing. Environmental contamination is a major risk. And the course of this UGC program for next few days is basically focusing on pollution. So environmental condition because of chemical, physical, or any other biological mean is very important to understand and address. Now, why land degradation? As I mentioned, restoration is very important, but at the same time, we need to understand that if we don't address land degradation, the health of ecosystem is going to be deteriorated. Many of you might have heard about the Species Survival Commission of IUCN was having a red list for a species. But if you know that it started in 1960s and till now, after almost 60 years, we are not able to actually have all the species being addressed, all the species being assessed for species red listing. That's why we need this umbrella approach of IUCN red listing of ecosystems. This has been an ongoing approach for last almost a decade across the world, where Australian continent, many parts of Europe, many parts of Latin American countries and their ecosystem have been assessed for their red listing. But unlike species that they go extinct, they are not able to survive if their habitat is lost. Ecosystems don't go extinct. So basically, ecosystems collapse. If you see many situations across our country, we know that ecosystems are there in pristine, undegraded state. But the moment we start extensive land use, be it for urbanization or agriculture or mining or any other reason, this extensive land use, the moment it turns into intensivization, it leads to a stage where ecosystems, landscapes are not able to give you the kind of requirement, the kind of benefits you want to harness. For example, if we see agriculture intensification, it's the stage where we are maximizing the benefits from the land only for food production. But there is a moment where food production is also not possible because of the extensive use of chemicals, extensive use of fertilizers. We have degraded all kinds of ecosystem services, and this is the stage of ecosystem collapse. So the trade-offs among ecosystem services from undegraded state to abandoned ecosystem are very high. And this was also confirmed into 2018 IPBES, the Intergovernmental Panel on Biodiversity and Ecosystem Services Assessment Report on Land Degradation and Restoration. After Global Biodiversity Framework was confirmed last year, it is now a necessary for all the countries, including India, to include ecosystem health assessment in their National Biodiversity Strategy and Action Plan. Now, when I talk about deforestation, forest degradation, and massive loss of biodiversity across the world, we know that humans have altered more than 75% of terrestrial habitat, terrestrial environment across the world. And this is majorly by drivers like urbanization, mining, change in land use, and so on and so forth. But the impact of the 75% altered environment has an impact on more than 30% reduction in habitat of animals as well as plants across this world, in not only in modified ecosystems, but also natural habitats and ecosystems. If I see global food system, agriculture intensification, this has been for the fulfillment of nutritional and food requirements of people and rising population across the world. But this has been a mega threat. It has led to almost 86% of species at the risk of extinction. And this extinction risk is rising. And this is alarming because a lot of pollinators that are pollinating our crops are also under threat. If we see the traditional and historical record and statistics of how food production has increased over the time, we know there has been exponential rise in food production. So since 1970, we have almost 300% increase in food production, and this has taken about 23% of land areas where productivity has reduced because of land degradation. So now you see that land degradation is going to increase exponentially, and it will be a major precursor, a major driver for loss of not only ecosystem services, but also if land degradation is increased, it also reduces our productivity to fulfill the food requirement, the nutritional requirement of ever-growing population of humans on this planet. I want to share these three important reports that came in last 2 years. You know that climate change report in 2021 was a physical science report that showed that we on this planet have already crossed our carbon budget. And that is one of the reasons we just have another 6 to 7 years to ensure that we don't surpass, we don't go beyond that, and we don't rise the temperature of this earth. That's why a few years back, the threshold was given of 1.5 degrees centigrade to keep the temperature rise only up to 1.5 degrees centigrade. But unfortunately, because of the ever increasing developmental pressure and anthropogenic activities, we cannot say anymore that we are going to reduce or we are going to stick to 1.5 degrees centigrade. This might be 2 degrees centigrade, this might also be 2.4 and 3.0 degrees centigrade, because the business as usual scenario is very much prevalent across this world. Another report that came in 2022 talked about impacts, adaptation, and vulnerability, and I don't need to show or confirm how this vulnerability is arising across this country. You know the kind of floods, western disturbances, and extreme climate events the northern part of the country is facing, the coastal area of Maharashtra is facing, or other parts that are reeling under the drought in the season of monsoon. So the land degradation report was the first one in 2018 to showcase how land degradation, the risk of migration, the risk of increasing disaster is very much interlinked with loss of biodiversity. These are another two reports that came in just last year, the global assessment report that talked about 1 million species on this earth that are under threat to go extinct. The another report came in July 2022 and talked about sustainable use of wild species. You know that last few years were a major stress for the entire humanity because of the COVID-19 pandemic. So if there is extensive land use, land cover change, there is exponential rise in unsustainable use of wild species, and also increase in trafficking of wild species, there are chances we will meet more spread of zoonosis in coming years. Now, so far, there has been a thought that climate change and biodiversity are two separate subjects, and they have to be dealt by two different kind of experts. Whereas this recent report that came in 2021 and 22 showcased that biodiversity and climate change are no separate topics, no separate subjects to deal with, because the problem is very much interlinked, and these problems of climate change are going to accelerate biodiversity loss because the niches of many plants and animals are going to change, and this will lead to extinction of more species. And the loss of species and ecosystems is further going to accelerate the pace of land degradation across the country. Now, another important highlight that I wanted to showcase is the last climate COP that happened in Sharm el-Sheikh in Egypt, and it highlighted the protection of biodiversity, understanding the global crisis because of biodiversity loss and climate change, and using nature-based solutions or ecosystem-based approaches for conservation and increasing adaptation and mitigation due to climate change. This is the another global biodiversity framework that was accepted just after the climate COP. And it also had the similar kind of outlooks and results and conclusions, reducing threats to biodiversity, meeting people's need through sustainable use of wild species and benefit sharing, and then tools and solutions for implementing and monitoring so that we know that where species are getting lost, and we have more evidence-based decision making, data-driven decision making for conservation and restoration of these species. Now, bringing your attention back to the country, I'm not sure from the background that you all come from, but one thing I want to share that if you know that our country is having 10 important biogeographic zones, right from the deserts to coastal to arid to semi-arid, and so many other biogeographic zones, we have 16 important forest types. The forest types of India was first given by Champion and State in 1968. And at that time, this country was having huge area under lush, green, pristine forest. But in 2015, when then director of Indian Institute of Remote Sensing, through extensive data extrapolation and remote sensing exercise, they got to know that our pristine forest types are no more pristine and closed. Our forests are changing very rapidly, and there are more mixed forest formations, more managed ecosystems like orchards, tea plantations, coconut plantation, mango orchards, scrub lands, grasslands, degraded formations, plantation. So our ecosystems are changing, our natural forests are getting more open and more encroached by anthropogenic pressure. Now, If you see the kind of forest right now in India we have, even the forest in biodiversity hotspots like Western Ghats, Eastern Himalayas, coastal areas, and also in islands of Andaman and Nicobar are degraded. And this massive loss of forest is going to affect not only climate related vulnerabilities, but will also reduce the kind of provisioning, regulating, supporting, and cultural benefits this country is getting from these forests. Now, taking you back from land degradation and the kind of economic losses South Asia has, we every year are in the South Asia alone are losing a lot of monetary benefits to land degradation. If they see it in numbers, it's about US dollars 10 billion annually that is lost to land degradation. And this is equivalent to 2% of GDP and 7% of the value of the agriculture output from this part of South Asia. If you see this interesting paper by Gibbs in 2015, you know that our country and China are one of the top areas where massive land degradation has happened over the years. And this land degradation in total is about 490 million hectare. India itself have almost 90 plus million hectare under land that is degraded. So there are many reasons to which land degradation happen. So drought related economic losses are part of land degradation. We know that Vidarbha part of Nagpur in Vidarbha is also reeling under different kind of this disaster risk. And one of them is land degradation. And also you get to know a lot of farmer-led suicides because of this land degradation. And this increasing vulnerability of droughts is increasing. And this is becoming kind of a new normal for everyone. India, as I mentioned, is having more than 96 million hectare of degraded land, and this may lead to more than 1,730 billion loss for India by 2050, and that's a significant amount. Agriculture intensification, mining, and urbanization, according to us, are some of the three important mega drivers. Exponential population growth, requirement of food, energy nexus, and other developmental demands are further going to aggravate this issue. Now, if you see India as a whole, there is almost 42% of land that is under drought, and there are more than 500 million people across the country that are affected. So if you see severely resilient, non-resilient, moderately non-resilient, and severely non-resilient, you see a larger part of west part of the country is having severely non-resilient. And Maharashtra, Rajasthan, and parts of Gujarat are also reading under this non-resilient landscape. So as I mentioned, drought hits many parts of this country every year, and almost 500 million people are thought to be really affected, and that's about 40% of the population of this country. There are these states: Andhra, Bihar, Gujarat, Jharkhand, Maharashtra, parts of Northeast, Rajasthan, Tamil Nadu, and Telangana. So despite if you see the northeast part of the country where we see some of the high rain intensity areas are there, they are also the areas where a lot of drought happens. The situation in Maharashtra, Marathwada, and Vidarbha is considered to be worse. And with 80% of districts in Karnataka and 72% in Maharashtra, every year they face water shortage, water scarcity, and crop failure. And the major reason is less rainfall, more dependency on groundwater, and agriculture intensification using crops that are water intensive crops. So it's not only livelihood loss, it's not only unemployment, but also forced migration that happens and leads to more migration in urban areas and exerting more pressure on urban areas. So in a kind of work that we do in our department is critical zone research. And in this critical zone research, we have a 135 square kilometer observatory in Narkhed Pandurna area. And in this Narkhed Pandurna area, we try to work with a multidisciplinary approach, right from subsurface level to canopy level, to understand what might be the major reasons behind loss of ecosystem services if our watershed is agriculture intensified watershed, and what kind of pressure it can exert on other natural resources. So in this watershed, we also try to understand the precision irrigation demands and requirements especially for orange horticulture. And we saw that the present irrigation practices that are more groundwater dependent are exorbitantly high. And our measured water uptake and our 1 year of work understanding the sap flux analysis showed that a tree basically needs 5.6 liter of water per day instead of the one that is projected to be as the requirement. Now, if I want to understand how these forests are undergoing rapid degradation, we all know that biota and water are quite both two sides of a coin, where we say that biota regulates hydrology, and hydrology in turn also regulates this biota. So these floral plant combination and groundwater dependency is very much interlinked. And at the same time, it's important that we understand their interfaces and deliberate actions by humans that are changing the ecosystem properties. So the pictures that you are seeing on your screen is from Northeast and one of the NGT cases that we did in East Clariat area. And we found that rat hole mining has changed the entire landscape and many parts of the ecosystem of these high value conservation landscape and a biodiversity hotspot in Northeast. And now even the pH in the river is very low, about 3 to 4. And also if you see, there is no, and there is a prairie-like characteristic, a grassland you see in this picture, whereas this is not a very natural characteristic of this area. So this transformation of this landscape because of human interventions is degrading this ecosystem and also affecting the hydrological properties of this area. Similar is the case of riverine and wetland areas, where now we see that there is no riparian buffer that is left without human encroachment. Similar is the case of wetland. Recently, we were doing a study in wetlands of Nagpur, where we were trying to understand the green-blue buffering, the ratio of green-blue buffers in these areas. And we find that over the years, the catchment area has been concretized and more infrastructure has built up, has resulted in loss of surface flow to these lakes. Another important area and reason behind increasing disaster risk is increasing loss of ecosystems and vegetation from these areas, be it riparian buffers or you see other mountain related vegetation over the years because of urbanization, because of agriculture or horticulture intensification, as also in the case of Himachal Pradesh, road construction, road broadening, by ensuring that a lot of natural ecosystem gets lost, this has exerted a lot of pressure on these pristine ecosystems. We know that mangroves have been a huge ecosystem, resilient ecosystems, and also support for coastal areas. But because of development in coastal areas, again, these mangroves are affected and they are now degrading and they are not able to withstand a lot of cyclones and climate change impacts that are hitting our coastal areas. For example, if I talk about coastal areas, we know there are mega drivers of mangrove loss as well as terrestrial vegetation. Sea level rise and cyclone and sea surges are happening across our coastal areas, be it east coast and west coast. And those of you who have seen coastal area or you live in coastal area, you know these kind of drivers are very much prevalent in these coastal areas. We were working in Bhitarkanika under one of our projects, and we tried to understand what affects these mangroves and what are the mega drivers of mangrove loss. So these are some of the human interventions. You can see upcoming resorts, grazing, aquaculture, settlements, brick kilns, agriculture intensification, and concretizing the banks, the coastal areas are some of the important concerns. And if you see in Bhitarkanika also, there are a lot of aquaculture farms. Now these aquaculture farms are having more productivity, and to increase the productivity, they use a lot of hormones and chemicals. And many of these hormones and chemicals are endocrine disrupting hormones. And when they are released in the water, when they are released in coastal waters and the nearby sea, they are exerting more pressure on the quality of water the quality of aquaculture, and the quality of fishes that are found in natural waters. And then you see also forest is cleared for agriculture. So this kind of pressure is also there in coastal areas. And then you see aquaculture farm at the fringes and settlements now fragmenting the forest area. So even these pristine area, mangrove areas are now getting fragmented. But other than low scale impacts, there are large scale impacts like expansion of roads, conveyor columns, conveyors, industrial complexes, fertilizer plants, urea plants that are coming in these areas and exerting more pressure on these natural ecosystems. But what we have observed through our study is loss of ecosystem is not only going to increase disaster risk, it is also going to reduce flow of provisioning benefits, direct use values that local people are dependent upon. And once these provisioning services are restricted and reduced, there are chances that communities have to walk longer distances for water, for resources, for fuel wood, for fodder, and so many other requirements for their subsistence lifestyle. And this enhanced input in terms of time and labor will affect their education, will affect their health, and also affect their social environment. So you can see that local socioeconomics and loss of ecosystem have a very far-ranging impact than what we otherwise thought of. Increasing climate vulnerability, it's everywhere. It's in the West Coast, it's in East Coast. You go anywhere, you are now able to see how our coastal landscape is changing because of the increasing climate vulnerability. The sea level is also rising. We try to understand these potential drivers of mangrove loss in both East Coast and West Coast by trying to understand the uncertainty, acknowledging the uncertainty, and trying to understand the impact. And we found that there is a huge impact on both the ecosystems, on both sides of coastal areas, that is going to impact provisioning benefits, regulating, and also other kind of ecosystem services. Now, when I talk about climate change and its impact, it's very important to understand that land degradation is very much linked. We try to understand the impact of climate change in coastal areas. I showed you some of the results because how people perceive climate change in the area. We also try to understand Banj oak because one of the Niti Aayog reports says that loss of spring shades in mountain is because of climate change, and specifically one kind of species, that is Banj oak or Quercus leucotrichophora. We used almost 30 years of data from publications. We used our own work areas, about 30 points of occurrence, and then we try to understand and use locations from Global Biodiversity Facility, GBF, and we found that the projections are that, according to IPCC, the projections are that by 2050, the potential habitat of these species will reduce by 80%. And there are chances there will be more upward movement of these species. Now, potential habitat reduction is significant if you see 80%. And upward movement by many of you can be seen as a positive step, because upward movement means that species will find somewhere a niche, a habitat to survive. But at the end of the day, this will be at the cost of other threatened species that are found at that higher altitude. Similar was the case of riparian buffer species of Hippophis salicifolia, one of the high value species. We found that the ecosystem impacts and climate change impacts on the ecosystem are severe. And by 2050, the species will lose almost 87% of its habitat. And they will be further increased by 2070. But this increase, if you see, will be very nominal in what we have lost by that time. And another study, another species in Kashmir is what we worked on, and because a lot of local communities are dependent. So all the species that I presented in this presentation are the species that are used by local communities, and these are going to be lost because of reeling climate change. And if we add the impact of human-led degradation of these landscapes, the impacts can be manifold. So one thing is very clear that I also stressed in the starting of my presentation, that ecosystem health assessment and risk assessment becomes very necessary in our country, where we knowing that most of our ecosystems are getting degraded. So Red listing of ecosystem is a fundamental basis for designing need-based and evidence-based strategies to avoid risk and informing conservation planning policies and land management, and having a prioritized approach and a crucial information on threats and drivers of biodiversity loss that I presented how we have collected, and linking them with global typology of ecosystem so that we know where risks are, we know the causes and pathways of ecosystem changes, we know the severity of threat to design solutions, and we also understand which are the most compromised ecosystem processes. Now, if I try to summarize what I have presented so far, excuse me. So if I try to summarize what kind of land restoration challenges our country faces, one of them is we don't have identification of priority areas for restoration, and we don't have enough estimations of their benefit and cost. So this multi-criteria optimization approach is very much required. If you see every year, plantation happens during monsoon period, but we don't have monitoring, we don't have a review of what we are doing, we don't have validation. So MRV is very much lacking. Lack of people-centric approach. Recently, one of our publications for the country stressed that most of the opportunities on restoration are not in public lands, not in forest areas, but in private lands. Lands where agriculture is happening, land where gardens are, land where private access is. So this is where people-centric approaches becomes very necessary. There is still shortage of legislation despite country having some of the best policies how to incentivize ecosystem restoration. We know that communities are involved, and if we want to have more people-centric approaches, we'll need more incentivization of ecosystem restoration approaches. And then, of course, also to highlight lack of convergence among different government line departments and private sector financing. Because one of the reports in 2021 by United Nations Environmental Program highlighted that localizing and upscaling nature-based solution requires more funding. So this funding should not only be coming from public sector, but it should also come from private sector. So corporate involvement in these activities will be really helpful. And of course, as I highlighted, monitoring. We do in India a lot of restoration, and we do definitely generate a lot of big data. But how to ensure post-plantation care, because insufficient long-term research on planted mangroves and forest areas will lead to more losses and more land degradation across the country. So what we need to understand in this context is realizing that disaster risk is going to increase. It may be manifold. We have seen some of the evidences in last few years, even this year. And we also need to realize we actually don't have enough time. We know that carbon budget, we have already surpassed the planetary boundaries. So our decision time has to be very short, and implementation time also has to be very short, involving all kind of stakeholders. So if I say stakeholder, that also means academicians like you, who can help researchers understand these more specific local context, more specific local requirements to plan and research on these areas and provide novel and innovative solutions to not only local bureaucrats and stakeholders, but also policymakers. Understanding what to plant, right species at the right place is very important, and ensuring right-based approaches that can be really helpful. And I should also say this subject should not be limited to a biologist, a ecologist, or a botanist or zoologist. This is an area where multidisciplinary research is very much required. The one that we are doing in critical zone research, we have about 5 or 8 observatories across the country. NIRI is one of the observatories. So we need more other domain people in this. We need more economists. We need more engineers. We need more pedologists, hydrologists, geophysicists, geologists in this domain to understand the entire ecosystem, the entire system, and accordingly provide better solutions. So one thing is clear, that nature is definitely matters. It definitely matters for developing resilient societies and resilient ecosystems and resilient cities for the future. And we have enough proven potential. I've already showcased some of the examples how harnessing nature's contribution to people can improve human well-being. We tried to bring in these two important contexts in last few years. One was nature-based solution, because you know this term is a more global and a Western word-generated word. Whereas if you see, we have more solutions and approaches scattered across developing and underdeveloping countries and global South. So we try to collect these information from different parts of Asia and present what we can do in our natural ecosystems and urban areas to improve resilience and sustainability context. Nature-based solution and restoration is basically not us helping nature, because even if we don't give any inputs, the ecosystems are going to be restored back. Because you know, restoration can be done in two ways. One is human-assisted regeneration, another is rewilding. If you introduce a species and ecosystem itself takes its course for restoration, it's rewilding. And when that is human supported, it's restoration. So this is very much necessary. This was one of our primary work that we did on developing a climate sensitive restoration approach. How in primary planning phase, what kind of acceptance of uncertainty has to be there, understanding and accepting climate change, integrating different knowledge systems, be it state of art, remote sensing, or modeling, or other kind of scientific approaches. We also stressed on including local and indigenous knowledge systems. In implementation stage, I and we personally stressed on involving more local communities, because they know where exactly their degraded areas are, which areas need to be looked into priority, what kind of species, what kind of underutilized, lesser known wild species need to be mass propagated by seed collection or vegetative propagation, and how communities can be involved in land preparation and plantation. And this can be a good livelihood opportunity by ensuring that corporate get involved in this entire program. And of course, involving citizen scientists, artificial intelligence, and big data based approach for post restoration and monitoring. So this is how we can not only achieve the UN target of restoration by 2030, we will also be able to achieve a lot of targets of sustainable development goals, the basic biospheric goals of 14, 15, 5, clean water, life above land, life below water, and also 13, climate action. This is what we can achieve. And one thing is also, as I mentioned, there is a huge possibility of restoration and agroforestry areas. Agroforestry, as you know, is a very traditional practice across the country, where local people, farmers have been doing it in their backyards, in their agriculture field, by agroforestry, agri-silvi, agro-horticulture. So there are n number of possibilities how this has been done. And this is also the area where there is a multiple tons of carbon that can be stored and generated sink. So this is an excellent approach where existing land uses can be used for forest restoration. We also need enabling policies, as I highlighted. This is one of our recent paper this year that came in Nature, and there we highlighted almost 579 districts. Among them, about 116 have predominantly high biophysical restoration potential. And why it is necessary to look beyond carbon and look towards land degradation issues that can be solved by using customized local solutions. As I mentioned, these are different kind of agroforestry approaches, shifting cultivation in northeast areas, plantation-based cropping, scattered trees, shelter belt in coastal areas, boundary planting, live hedges, industrial plantations like poplar in the country. Earlier, eucalyptus was also used for industrial plantation for matchstick or for paper. Bamboo is now being used. Silvipastoral, hortipastoral, tree on rangeland. So there are, and then of course, home gardens, ecoforestry, and apiculture. There are all these traditional approaches that have been used for adaptations. Now, traditional agroforestry is a very important nature-based climate solution that can reduce land degradation and also improve climate sinks, carbon sinks for the country. So this can be in arrangements where managed peaceful regeneration happens, agroforestry happens, and adaptive agriculture practices happen. We came up with a publication in 2021, and this is one of our highest cited publication where we tried to showcase how agroforestry is capable to achieve a lot of global climate and adaptation targets using land degradation, land restoration models in South Asia, and what is the preparedness of the country. You know, India has been a pioneer in having the first agroforestry policy in the world, and then following it, the South Asian Regional Cooperation developed a Sarkopa initiative for agroforestry, where now countries like Nepal and Bhutan also have their agroforestry policy, where Bangladesh and Sri Lanka are going to develop next. Government of India is also trying to have a lot of corporate social responsibility funds to be invested in developing agroforestry model. For example, you know, in Madhya Pradesh, Moranga is grown and is taken as a next generation agroforestry crop and can be a very important future food. We also know that Pongamia can be a very good bioenergy plantation, not only for farmers' land, but also for mining degraded areas. And one thing is very important to highlight here, that recently in one of my visiting scientist fellowship to Indonesia, we saw that these bioenergy plantations, as per Government of India's first, second, and third generation bioenergy policy, have a huge potential not only to reduce land degradation, but also provide incentives and livelihood to communities, because there is a lot of private sector involvement in these bioenergy plantations. Global challenges, as I highlighted, monitoring is one of them. Financing restoration, collecting people in restoration is a major challenge. That's where governments have to work. That's where corporates have to support governments. And then we have already, India has joined the Bonn Challenge for Forest Landscape Restoration in 2020. Then in Delhi Declaration of UNCCD in 2019, Government of India has increased their targets of land degradation restoration from almost 21 million to 26 million hectare. And then recently, by projecting the NDCs, the nationally determined contribution, now Government of India wants to create carbon sinks through restoration of degraded lands, and that is equivalent to 2.5 to 3 billion tons of carbon dioxide equivalent. So this is almost 31 million hectare that India needs to plant. And would also like to highlight that we recently also came up with a publication on how the Glasgow, where Prime Minister went and talked about the Panchamrit targets, decarbonization economy, and how India will follow a decarbonization economy and achieve this target by 2070. We also developed a roadmap how India can achieve that. So there is a huge potential. India is already having a lot of national afforestation program, National Mission on Green India under National Action Plan on Climate Change, National Biodiversity Action Plan. And then you have recent, if you have seen recent budget, the Mishti Pariyojana, where government is targeting mangrove conservation, are some of the important concerns. The Manregas, wage against work, 100 days of work against 100 days of work with wages, is something among about 250 different activities where government is providing wages to have almost 250 activities to conserve, reduce land degradation, and also do other kind of national rural livelihood improving activities. So there are n number of these opportunities that government is creating, then also corporates are creating. I would also like to highlight the Nagar Van Yojana in urban areas. Government of Kerala is also doing something on lines of Manrega in urban areas. That's very different than other parts of the country, where state governments are also improving activities to reduce land degradation, reduce risk because of these urbanization or agriculture intensification, and so on and so forth. So this is one of the approach that we have been stressing on, the right approach, the 4R approach, using right species at the right landscape, at the right cost, and the right based approaches, so that we can actually localize a lot of sustainable development goals. And what can be the right approaches? So we also developed a pathway of 6 steps to 4R approach by developing and mainstreaming national level landscape restoration guidelines, using locally relevant knowledge for addressing critical gaps, identifying institutions and their roles, developing local capacity, leveraging technology to facilitate decision making. That's where scientists and academicians and researchers like you all can play a huge part. Encouraging multi-stakeholder involvement, promoting inclusiveness and community participation is something that can be a game changer. We are also doing something on biomonitoring and this continuous biomonitoring in our projects in central India, also in parts of Odisha and also parts of Rajasthan has helped us to develop this biomonitoring supported land restoration to ensure that in the course of restoration, we don't accelerate the heavy metal contamination in land and leading to trophic level contamination. So our close focus is on that also. And this approach is implemented in parts of mines of Tata and Nalco. And then, of course, the kind of big data that we are generating, it can be a transformative approach for long-term restoration. You all know that, and maybe if you're not aware, long-term ecological research is a very important area of work. There are multiple observatories across the country and also across the world. But so far, the amount of restoration, the amount of plantation we do during the monsoon season, every year, we don't know what is happening with them, what kind of records we have. If we can use this information for improvising and improving our and retrofitting our strategies for future plantation. So this is something where big data analytics can play a big role. So as you know, there has been a long presentation on understanding the risk of land degradation, deforestation across the country, across the world, and also parts of the region in our subcontinent. But what can be better take home messages from the stories that I have shared, from the instances and the research findings that we have shared? We need to focus on landscape because interventions have to be based on local landscapes, more customized. We need to understand that stakeholder engagement is important, and especially the vulnerable groups, because they have more understanding of these landscapes. Understanding that it's not only land restoration, it's also restoration of ecological functions that is important for not only humans, but also wild species, both flora and fauna. And then we don't need to have a one t-shirt fit all kind of approach. We need to have a variety of restoration approaches, combine suitable technological strategies. For example, for mining, it can be a biomonitoring supported land restoration, because we know that many heavy metals have this tendency of bioaccumulation and biomagnification. So biomonitoring can really help. Whereas in areas where such things are not prevalent, right species at the right place is a better approach. And then also keeping climate sensitivity in mind. Our entire focus should be conservation and enhancing natural ecosystems, so that these recovery and conservation of forest remnants ensures and reinstates these ecosystem services back to, not if not original, at least to a better previous situation. Customized approaches, as I mentioned, it should be customized to local social, cultural, economical, and ecological context. And then restoration should be for a subsistence requirement, supporting subsistence requirement of diverse stakeholders. This can improve soil fertility restoration. Even in agriculture fields, these restoration strategies can be done, because a lot of fertility of these agriculture soils have gone. Reducing erosion in areas where erosion is a problem, improving the shade thing, timber and non-timber forest products. And whenever we create these restoration approaches and models, we know carbon storage is going to increase, and fulfilling the requirement of government for increasing NDCs, increasing downstream water supply, ensuring the species that are improving the aquifer recharge in the area. And we also need to understand that these restoration approaches need to be retrofitted according to environmental conditions, because our climate is warming, our climate is changing. There are chances what we are planting today might not be able to survive in future conditions. So these changing climate conditions should be very much priority. and researchers and scientists like you can play a big role in this. So this is what I wanted to present. I thank you for your attention, and I'll happy to answer a couple of questions if you have about this presentation, or a little bit if I can answer beyond this presentation as well. I thank you once again for your patience and patient hearing. Thank you. Then I think you are muted. Yeah.
I think, madam, there are some participants, those who are interested in interacting with you on the topic of this.
Yeah, I'm happy to answer if there are any questions.
Dr. Anjali Mahagalkar, Archana Mahagalkar.
Very nice information you have shared, ma'am. Actually, I have one doubt ki, what the government is doing. So already you answered that question. Can we achieve the balance of this restoration and land degradation?
Thank you for your question, madam. I think that's a very important, pertinent question that you have asked, how you balance land degradation and restoration. I think if you see the rate of land degradation is quite high than the amount of restoration we are doing. And the reason is land degradation is because of multiple factors. They are anthropogenic as well as natural. So when I see natural, it's because of various climate related extreme climate events, like if you see in Himachal and Uttarakhand, and even parts of coastal areas in Maharashtra, landslides and massive floods have eroded a lot of soil, eroded a lot of landscape, and resulted in massive land degradation. But if you see restoration of these lands, it will be very tough to do it in a year or so, because you know that the pace of restoration follows the course of nature, and the course of nature is not so such an accelerated pace. Even if I have to stand a forest, I think we'll need at least 5 years to leave the area as such to restore it back. So the only effort what we can do, and then you also know that plantation have a season in India. Most of the plantation happens during monsoon season. But if we do have a planning of understanding where our priority landscapes are, what kind of strategy we are having, and then of course we don't rely only on the forest department to do this activity or corporates to do our activity. If a citizen on their bit can do some plantation and ensure that it's well taken care of, well monitored, well post plantation care is taken, I think at some way we can achieve. If you see the kind of the target government of India has, almost 31 million hectare. That's quite a huge target, because that has to be achieved by 2030. And I should also aware you on one point, that the approach of using land restoration or biotic interventions to control climate change is only 7 years, next 7 years. So by 2030, if we are not able to use our biotic interventions to control climate change, we will not be able to actually reduce this increasing temperature and extreme weather conditions. So in that scenario, we need to shift to other approaches, for example, carbon capture and other upcoming strategies. So decarbonization has its own phase. So this phase of next 7 years is going to depend on restoration. And it's definitely very tough to keep pace with land degradation and doing equal amount of restoration, because land degradation is happening every year, whereas restoration is not keeping pace with what and how much we are doing land degradation. So there was this interesting terminology also used by United Nations Convention on Reduced Desertification, UNCCD, and the headquarters are in Bonn and Germany, and they talked about land degradation neutrality, the LDN concept. So LDN concept says that we will not only restore what is degraded, we ensure that there is a land degradation neutrality. We will restore that much that even if there is a land degradation happening, it will compensate that. But unfortunately, it is very tough, and it takes a lot of involvement of diverse stakeholders to reach that pace reach that target of land degradation neutrality. I hope I was able to address some of your concerns that you raised.
Yes, thank you very much, ma'am.
Thank you.
Any participant would like to ask any question?
One question. Can't we stop this use of chemical fertilizers and hormones, as you said, in agricultural sector?
I think I mentioned two things. One thing was using hormones in aquaculture in the coastal areas wherever
Yes, you said that hormonal diseases also they are passing through the plants and food to the human body. So why should not we take the strong steps to stop this agricultural means chemical fertilizer and hormones? That's
I highlighted two important points. I highlighted that in agriculture intensification, we are using a lot of fertilizers and pesticides. Many of these pesticides are persistent organic pollutants. So these persistent organic pollutants are, for example, we worked on 2,4-D, that's one of the oldest herbicide. Then we also have glyphosate, and you know that how harmful glyphosate are. There are instances wherein in one of the districts in Vidarbha in Yavatmal, almost 67 farmers were died just because of use of glyphosate few years back. Because most of these chemicals are carcinogens and they are persistent in the land for a very longer time and they don't degrade. And even if they degrade, the byproducts are sometimes even more toxic than the original chemical. And by one trade name or other, they are coming in the market. If you see the similar case of fertilizer, more fertilizers are used by farmers, and many times they don't know if their land actually requires that kind of fertilizer or not, because these fertilizers are for nitrogen, phosphorus, and potassium. But many times they don't know even how much of nitrogen is required for their land, and many times you know that nitrogen is mostly fixed by these smaller microorganisms. So this external supply of NPK, and if there is more flood irrigation taking place, a lot of nitrogen actually goes back in the environment. And when it goes back in the environment, it becomes more toxic. And that's why our country has more nitrogen hotspots also because of vehicular or agriculture intensification. And now talking about the hormones, it's not only in aquaculture, even if you see the livestock, the kind of milk that we are having is also having a lot of hormones. A lot of vegetables that we are having, a lot of hormones are there. So now they are actually having a lot of diseases for humans because most of these hormones are endocrine disrupting hormones. And many of these hormones are one of the reasons of accelerating carcinogens in human body. So one thing is that I would say is awareness. Awareness is important.
Yes.
Not only among us, because many of us are knowing this and we try to, and we have this buying power also to understand that if we buy organic, that's again the second buzzword. If we buy organic, maybe we are able to save ourselves, but farmers need to be aware of this. I remember I was talking to one of the person from pesticide industry, and I was astonished to understand that even in mountain areas where we think the farming practices are more organic, for example, Himachal Pradesh, where from a lot of good apples are coming, there are no land where fertilizers are not applied. There are no land where pesticides are not applied. And that's why we don't see any bugs, we don't see any caterpillars, we don't see any insect anymore in our brinjal, in our lady's finger bindi. So one thing is, as an ecologist, what we have learned that if you are not sharing your ecosystem, if you are not sharing your food with another small insect, that means there is something wrong in the kind of food that is coming on the plate, and the situation is the same. So this is the exactly the best case of how these pesticides and these fertilizers have not only degraded the environment, but also contaminated the kind of food that is coming. And as I mentioned, awareness right from the very early education level where we are training young people about environment, we should also make them learn about the harmful impacts of these the pesticides, the chemicals, and also the microplastics that is coming in the environment. I'm not sure if you have read this book, but if you get a chance, please read this book, The Silent Spring. I'm sure you will like to read this book by The Silent Spring book is by, let me remember the author. Yeah, the book is by Rachel Carson. And I think this is one eye-opener book that every scientist, every academician in this country should read. The ill effects of chemicals on not only land, but our human body.
Yes, thank you, ma'am.
Thank you.
Yes, ma'am. This is very right that it should not be related. This should not be the concept of scientist only. Every layman, and right from the child education, it should be put on this syllabus and curriculum also, that such uses should be stopped. Thank you, ma'am.
Absolutely. Thank you. Are there more questions?
Anyway, thank you, madam, for your valuable time and enlightening all the participants on the restoration of the degraded land in the warming world. I'm happy to note that you have shown few research paper with highest impact factor, and you have suggested the very nice book also. So I hope that all the participants will really enjoy your publication, your book, and also your presentation. Now I would like to request Ms. Kanimozi, please propose the formal vote of thanks.
I thank Dr. Shalini Dhyani Madam on behalf of every participant here for giving a brief description about land restoration challenges our country faces and the factors which contribute to the same. She also explained the interlinkage between diversity and climate change, how our coastal areas get disturbed. She also touched upon various research studies pertaining to the same in areas like Nagpur, Orissa, and Kashmir. At last, we concluded our session by highlighting the role of 4R approach, multidisciplinary approach, traditional agroforestry approach, and people-centric approach and the government policies in balancing our climate change and land restoration. Thanks a lot, Mama, for your wonderful session.
Thank you, Dr. Kanimozi and Mishram sir, for finding presentation once again. I wish you all the best for the rest of the lectures. Thank you so much and goodbye.
Now, Ms. Kanimozi,